Hey there! You're probably watching this video from inside a building. And if you're like many people, you spend up to 90% of your time indoors. So it's important to understand how buildings work. No, not that kind of work. It's important to understand how buildings interact with factors such as weather, including wind and temperature, and building heating, ventilating, and air conditioning systems, or HVAC systems for short. So let's dig into each of these. First, let's talk about weather. Weather effects on buildings include outdoor temperature. Colder outdoor air results in larger indoor-outdoor temperature differences. And this tends to increase infiltration, which is unintended air leaking into a building through the cracks in the exterior wall, around windows and doors, and other openings. Higher wind speeds tend to increase filtration. Wind direction will also affect infiltration, including how the building is oriented in relation to the wind direction. So how do these factors relate to the height of the building? All buildings have a neutral pressure level, or NPL for short. You might think that the neutral pressure level is somewhere in the middle, but it's not always there. It can move depending on the structure and the weather. For instance, if you have a chimney, the neutral pressure level, or NPL, will move up toward the top of the building. If you have a large opening at the bottom, the neutral pressure level, or NPL, will move toward the bottom of the building. Let's assume that the NPL is in the middle. In warm weather, the air will enter at the top and leave at the bottom. In cold weather, with no wind, the opposite will occur. Air will enter at the bottom of the building and leave at the top. So with stack effect only, and understanding where the neutral pressure level may be, as well as the weather conditions and what's going on inside, this may be the pattern of infiltration in your building. Wind also affects infiltration. In this diagram, considering wind alone, looking at the direction and the orientation of the building, we can see that the air enters in from the right, or the windward side, and leaves from the other sides of the building, or leeward sides. And when you combine the effects of stack and wind, you might have a diagram like this, where on the windward side, infiltration decreases as you go up, and on the leeward sides, exfiltration increases as you go up. Keep in mind that these examples just shown, with stack effect only, wind effect only, and combined wind and stack effects, were done in cold weather situations as well as with the building where the neutral pressure level was in the middle. Now let's move on to how building HVAC systems affect airflow. HVAC systems include central units that can deliver 100% outdoor air or mix outdoor air with recirculated air and deliver it to multiple spaces. Room units recirculate air, maybe bring in some outdoor air, like a fan coil unit. Some do not bring in outdoor air, like a window air conditioner. Lastly, there are exhaust fans that remove air, like those in restrooms and kitchens. Building HVAC systems may be set to operate all the time, like a restroom fan, or they could be operated only when events are occurring, such as kitchen fans and cooking. But very often, these systems are tied to thermostats. When the indoor temperature is at the thermostat set point, the fans will turn off. And when these units are on, they may pressurize buildings. And when exhaust fans are on, they may depressurize buildings. When all these things are happening at the same time, it's not as straightforward. So how do we know which way the air is flowing? It'll depend on many factors, including weather and building HVAC operation, but also building configuration, such as are windows or doors open, or are other things happening in the building that we don't know about. So the question of whether a building is pressurized or depressurized is a complicated one. Parts of the building can be pressurized at the same time that other parts of the building are depressurized. So how can we know what the building is doing? The first option is to measure it. But you'll need to measure at several locations, and this can be time intensive. Your second option is to simulate the building. And in our next video, we'll learn all about multi-zone modeling. So thanks again for watching. Take care.